Simpson math. In the previous video, we learned about the expected value of binomial distributions. In this video, we're going to look at finding the variance and standard deviation of those binomial distributions. So in the last video, we saw that to find the expected value or to find the mean, what we did was we just took the number of trials and multiplied it times the probability for success. To find the variance of a binomial distribution, remember this symbol is the variance. So to find the variance, we just take that same number of trials times the probability for success and multiply that times the probability for failure. Or you could just call this the expected value times your probability for failure. So we can just take our expected value and multiply it times the probability for failure to find the variance, how much our game varies. So, or how much our situation varies. So in this case, I already found that the expected value was 10. So to find the variance, what we do is we just take that 10 and multiply it times our probability for failure. Well, the probability to win was 1/4. So the probability for failure is 3/4. So 10 times 3/4 is equal to 30 over 4, or that's 7.5, 7.5. So the variance here, well, we found our expected value to be 640. So our variance here is just 640 times the probability for failure. Well, our probability for success was 80%. 100 minus 80 is 20. That gives us our probability for failure is 20%. So if I multiply 640 times 20%, I get 128. Here at the casino, we found the expected number of payouts was 2,250. So to find the variance, I just take that 2,250 and I multiply it times the probability of failure. Well, payouts was our probability of success last time. So the probability of the complement to that payouts is the 85%. So the variance of the payouts is 1,912.5. So that's the variance. Now to find the standard deviation, remember our symbol standard deviation, we just take the square root of our variance. This is just, notice it's just the square root of our variance. So we take the square root of n times p times q, or we can take the square root of just our expected value times q. Now we've found the variance for each one, so all we're going to do to find the standard deviation then is to take the square root of each one of those things. So to find the standard deviation, I'm just going to take the square root of 7.5, which is approximately 2.7-ish. And the standard deviation here is just the square root of that 128, which is approximately 11. 121, you know, is 11, so it's a little bit more than 11, like 11.3-ish or something. And then here, the standard deviation is just that 1912.5, the square root of that. So that's approximately like 43-ish, about 43-ish, a little bit more maybe than 43. So those are the standard deviations. Well, how can we use that? What's the point of that? Well, remember from Chebyshev's theorem that Chebyshev's tells us that at least 75% of our data is going to fall within 2 standard deviations from the mean, at least 75% of it. So I can look at this and I can say, well, my mean is that 640. So if I go out 2 standard deviations, up 1 standard deviation from that mean, and I just add that number, and I'm at 651, add another one, and I'm at 662, subtract a standard deviation from there, and you're at 629, subtract a standard deviation from there, and we're at 618. And we know that 75% of the time, according to Chebysev's theorem, 75% of our data should fall between this 618 and 662. So in other words, if every year I'm getting around somewhere between 618 and 662, that's kind of what I expect, that many seeds to germinate. But if I get something weird, like only 530 of my seeds germinate, then I go, hey, something weird happened that year. Something that's not normal for that number of seeds to germinate. So it kind of gives me an idea of how many seeds I can expect. And the same thing here with the casino. The casino expects to pay out 2,250 times a day. So if they've got 15,000 people coming in a day, then that's the number of payouts they expect to make during the day. Well, and they can tell you that because of Chebyshev's theorem, we know that 2 standard deviations out, 75% of the time, that's how many payouts there are going to be. So you just add that standard deviation on twice. So 2,293, add it on again, you get 2,336. And then you subtract that off twice so that you're at 2,207. Subtract it off again so that you're down 2,160, 64, I think. So brings me up to 107, yeah. So maybe this is not, yeah, 4 sounds good. So now I know 75% of the time it's going to fall within here. Well, if something weird happens and I'm starting to pay out every day 3,000 people, then I start to wonder what's going on. There's something weird going on. So this helps me to know and prepare as a casino how many times I'm going to have to pay out every time. So that's how we find the variance and the standard deviation, and kind of how we use that with a binomial distribution. Math made simple at Simpson Math. Thanks for watching.